Hello and welcome to the Conscious Design Podcast. I'm your host, Ian Peterman, and I help turn product ideas into sustainable seven-figure businesses. Join me for another episode where sustainability meets innovation and business savvy. Today, I'm really excited to have Julia Marsh. She is the CEO and co-founder of 𝗡cie, where they're using seaweed to replace some plastics and packaging, which is amazing. Welcome to the show.
Thanks for having me. Happy to be here.
Absolutely. Well, working in product development for a long time, I know just how much plastic goes into packaging. So it's a big thing to take on to go after that industry. Let's jump back into how did this come about? What got you to go, let's turn seaweed into a better material than plastic?
I come from the design world and was working with brands to build their packaging systems. So I was part of the problem, you could say, and came into contact with a lot of plastic. And also grew up in California and love the ocean. So I felt a sense of personal responsibility. The environment isn't a backdrop. We're a part of the environment, we're a part of nature, and we can't be perpetuating waste and designing systems that don't make sense. So I was drawn to this problem from a sense of personal responsibility and also just kind of disgust. Plastic is gross. It can be really gross. And I think that's kind of a universal feeling. And so why haven't we been able to design plastic out of so many systems, and in packaging in particular, because that represents nearly 50% of all the plastic that's used.
And it's always thrown away.
Yeah. And it's always thrown away.
It just goes away. It has a very short lifespan.
Right. Like the average retail bag when you go shopping has an actual useful lifespan of like 12 seconds. And then it just exists on Earth forever. Or like the flexible plastics that we get whenever we order something online. I'm really fascinated by flexible packaging because it's everywhere. And you know, I think the straw and the cup get a lot of attention because they're part of maybe the everyday, but then there's kind of the secret plastics that you don't necessarily think about as much, but that are very much a part of our everyday. When you open up a bag of cereal, when you order something from Amazon, when you open up your cupboard, you'll see it's all this flexible plastic and it never gets recycled. Like less than 3% of it ever gets recycled. The majority of it just ends up as trash.
Well, it's really hard to recycle, right? I mean, that's part of the issue is even if you were to collect it, especially all the food stuff, it's so contaminated for recycling. So flexible plastics, and they're everywhere.
They're everywhere.
We throw them all away. They never last. They're never really used in a way that's supposed to last very long, right? I feel like it's all a short term.
Basically all short term use, but then they do in fact last forever. And yeah, so flexible plastics on average, only 1% to 3% of them are recycled. It's quite rare. And so instead, they end up going to landfill, or they end up in, our cities or in the ocean or in natural spaces. I feel like I always see, plastic bags like the Katy Perry song, like blowing in the wind. And I'm like, man, it'd be so cool if that was made from biology, if that wasn't designed to last on Earth forever. And if we could create new materials that had the reality of our imperfect systems in mind, maybe we would start to not completely fix the plastic problem, but at least make a dent in it.
Right. And so how does seaweed play into this? Because, we think of that, you can eat it, it's a food, goes in the ocean. That's basically all the average person really thinks about.
Sushi.
Seaweed.
Yeah, sure.
Sushi. Yep.
Or
delicious,
or you've had
tasty.
Like a bad experience swimming and it's touched your leg and you thought it was something gross.
Oh, yeah.
Seaweed is full of potential. There is an industry dedicated to cultivating seaweed for its gelling properties. So you may unknowingly be consuming seaweed in your ice cream, it's in your toothpaste, it's in your facial cream. Sometimes seaweed is used as a foaming stabilizing agent in beer or coffee. Your agar petri dish is made with seaweed. So there's this ingredient that comes from seaweed that has this natural gelling property. And there's a whole commercial industry dedicated to cultivating and then processing seaweed to take advantage of that. And that's the same component I was inspired by. We now use the natural polymer, that gelling quality of seaweed, to create replacements for plastic.
Okay. So it's a naturally existing polymer that you're able to utilize in a similar way to how plastic polymer gets used in turning these materials.
Right. And the criteria that I was looking for as I was thinking about replacements for plastic is we have existing alternatives. When you go to Whole Foods, or maybe sometimes in just your online shopping, you may receive packaging that is labeled as compostable. And most of the commercially available compostable packaging is made from corn, sugarcane, potato, cassava starch. Maybe it's even like a wood pulp based bioplastic. And all of these materials, we actually do know that they work. They do actually biodegrade. Like, that data exists, but they all carry trade-offs in terms of how they're cultivated or sourced, or how much they cost, or how they perform to, protect whatever is being packaged inside of them. And so I was like, man, if we want to beat plastic, you also have to outpace the shortcomings of the alternatives. You need to source from a material that isn't resource intensive, that isn't a huge food source, that could be cost competitive, and that could perform to actually come close to matching plastic's great performance qualities. And that's how I arrived at seaweed. And that's really the foundation of 𝗚cie.
So let's talk about comparing, right? And you mentioned there's a whole bunch of others. Foreign plastic is packaging, right? We all have seen these things, and we all know, they're either super crinkly or they fall apart too easily, right? There's always, as you said, these trade-offs. How does seaweed as this material sit here compared to those? And, we have high performing but very unsustainable plastic as well. How does seaweed play against those products?
If you think about what seaweed's doing in the ocean, it's getting battered around by ocean waves, and it's been doing that for almost 1 billion years. So if you're looking at...
That's some practice.
Yeah, it's got a lot of practice. So if you're looking at what in nature is plastic-like, seaweed actually is pretty plastic-like. And we're really inspired by the inherent qualities of seaweed. Our job as a team of scientists and designers at 𝗚cie is to functionalize those inherent properties using traditional plastic infrastructure. So the benefit of working with seaweed, it doesn't just have to do with this awesome sourcing story. Seaweed grows on every coastline in the world. It's abundant. You don't need fresh water. You don't need pesticides. You don't need to feed it anything. It just grows in the ocean in these farms. But it also can be engineered to plug into systems that already exist. So we spent about 3.5 years trying to figure out how to make seaweed melt.
That sounds hard. That sounds like it would burn a lot.
It burns.
Before that.
Yes,
yeah.
Indeed. Yeah. Problem: seaweed, inherent strength, inherent plastic-like qualities, loves water, doesn't like to melt, wants to burn. So that was small problem that we spent 3.5 years designing around, and we ultimately did it. We created a pellet made from seaweed and plants. We call it thermoplastic seaweed, or TPC for short. And This is a pellet that melts and flows through existing plastic infrastructure. But instead of being made from plastic, it comes from the ocean.
I mean, so you're able to put that in an injection molding machine.
And you can create all kinds of things. Yeah. And then we use this as the base because it has a lot of inherently really cool properties. Again, that like the strength, the elasticity of seaweed that's already there. Seaweed really doesn't like oil. So if you have a packaging application that you want grease resistance, it's just baked into the inherent qualities of the seaweed. And then there are shortcomings too. Seaweed loves moisture. So if you want to package something that's wet, you're going to have a challenge. But the beauty of this pellet is we can blend it together with all different kinds of other materials to get the finished product or the finished performance that we want.
So are you able to blend it with other like corn and things like that and blend? Like what can you blend with it?
We can blend anything with it. Our profile is we want the material to return to nature after it's been used. This material is not recyclable, it's compostable. So it's meant to go in your home compost or your backyard compost or a commercial compost bin. And it's going to complete that loop of biological circularity from nature back to nature. So long as the material that's being blended together with this is compostable, we think that's great. And then it can go in all different types of places, all kinds of different applications.
And so seaweed material, it's not just industrial compostable. You can actually just throw this in the dirt anywhere and it will. Is that correct? Or do you have to industrial compost it?
No, so it's home compostable, which is, in my view, the gold standard for compostability. I think commercial composting is what's most accessible to most people. Most people don't compost at home, even though they should. But
Agreed.
but it creates this optionality. It's, I think one of my frustrations with recycling is recycling does work. For paper and for aluminum and for glass, it works really well. For plastic, there are a lot of shortcomings. And I think one of the challenges we're dealing with is that people have been disillusioned. They've read bad news about recycling and it makes them distrust the system. And so they don't participate in it. Composting is different. It's the one end of life that you can see happen right before your eyes. So you can mix our products in with not just dirt, but hopefully organic plants and food scraps and all sorts of things. And then with the combination of that waste and microbial activity and some moisture and some heat, it's this magic of you can watch the packaging return to nature. So that's why we've designed around home compostability and commercial compostability. It gives people that optionality.
Yeah, I love that. I agree with you that it should be the gold standard of being able to home compost because it is, even if it actually gets put in the trash, it'll still compost. It'll still break down.
It won't last forever. Yeah,
exactly. It won't just stick there and last forever like so many other things do. Now, you're able to use this in a few different ways. I know you can make a film. Like what all, because you said thermoset, are you able to make different materials that are not a film, or kind of where have you explored with this material being able to be used?
Our biggest focus is on flexible plastics just because they represent this category that is functionally never recycled. And I think that's a great place for compostable materials. Is recycling working here? If no, then maybe compostables are a good solution. So we're looking at the poly bag. This material, we're using TPC Flex, which is a blend of our TPC pellets to create a replacement for the poly bag that usually packages fashion items like shirts or shorts.
All those Amazon
things we get. And the poly bag is fascinating. There's 180 billion of them used in the fashion industry every year. And the reason for that is they have become essential in distribution channels where you don't want your beautiful new sweater to get snagged as it's being sent down these chutes. You don't want it to get dust on it. You don't want it to get moisture. You don't want it to be damaged during shipping. So you need the bag, unfortunately. But the problem is the bag never gets recycled and lasts on Earth forever. So we've been focused on replacing those with a variety of fashion brands. And that's our kind of biggest focus right now.
Hey, it's Ian here. So glad you're enjoying this episode of Conscious Design. If you want the full scoop on conscious design, what it is, how we do it, how you can do it, then check out our book. We wrote it so creative entrepreneurs like you can code social and environmental responsibility right into your brand's DNA. You can download the first chapter for free. Link is in the description. Enjoy the rest of the episode. Don't forget to like, subscribe, and share.
Yeah, I didn't realize there was that many bags, but it makes sense because the fashion world is so big. There's so many products made every year. Now, it has to survive a certain amount of time, right? How long
I've talked to some other people that they've made some materials, but they start to fall apart after like 6 weeks, right? There's a time when it just starts to decompose on its own. It's so easily biodegradable. How does how does that work for you guys? Because I know sometimes like you might make a shirt and it might sit there in inventory for like 6 months before it gets shipped. So how durable is it for those longer period? It's not 12 seconds. It's a little bit longer, but it's still in that less than a year. It's going to be thrown away.
Yeah, this is the tightrope we have to walk on, where we want the material to decompose as quickly as possible after it's used, but it also has to do this job, which is pretty rigorous. Your average shirt that's made overseas needs to withstand really high temperatures, a lot of humidity for a really long time, which sounds an awful lot like compost conditions.
Yes, it does.
So this is the challenge that my engineers and really any biomaterials company is confronted with. And I think I have two answers here. One is we hope that we have deployed this technology in applications where it makes sense. And if there's a reusable or package-free or really readily recyclable solution that works better, then I don't think our material should be used. I think it should only go in places where it makes sense to have a compostable product. The second piece is we're a materials startup that just launched this technology this year, so we don't have all the data yet. Very excitingly, we announced the launch of the 𝗶̈i Innovation Coalition in October. And this coalition is 4 brands who are all committed to testing our materials in these international shipping contexts to see how they really perform, and then to gather feedback from real people out in the world. And those brands are Prana, 𝗏𝗏, Florence, and Alex Crane, all fashion and outdoor brands that really are so committed to sustainability throughout their supply chain and are taking this leap of faith with 𝗶̈i to test our bags in the real world.
I love that. There's nothing more rigorous than putting the product through the actual life cycle of it.
It's a vulnerable thing to do, because the feedback could be good, it could be not so good. Well, we're going to find out.
Yeah, well, I mean, even if it's not good, right, it at least gives you a point to aim towards in improving the product. And I think that's, it is scary. It's a very vulnerable thing to put your product out there and just see if it survives. And that's the test. But that's great. So you have companies that are willing to do the test. You're able to obviously make the materials. When are you aiming to be able to go into production at the point where any brand could be like, hey, I'm launching a line and I want your bags for my clothes to go into? Kind of where are you hoping to have that?
Q1 of 2025, we'll have stock options of our bags. So anybody can go to our distribution partners and order bags from their marketplace starting at the beginning of next year.
Amazing. Well, that is super exciting.
We're in the scale-up process right now. It's amazing to watch something that started literally in our garage now at a stage where we're working with some of the largest plastic manufacturers in the country who are helping bring this material to production scale. We've come a long way in a short amount of time, and it's very much all thanks to people seeing the value of seaweed, of seeing the value of compost, and kind of reading the writing on the wall. It's like, we got to change the materials we're using in our everyday systems.
Yeah, well, and I think it's more and more people are expecting that our packaging and all this should be recyclable or it's kind of becoming more of an expectation. And I think that's where companies are seeing that and then going, oh, we don't know how to do that. And so then you can come along and go, hey, I have the thing that your customers are wanting you to have, and be able to produce it for them. Are you, so kind of company model wise, I mean, you're a materials company, you would work just B2B, then you are not a direct, like you have your suppliers and you work with other, because a plastics company can just basically buy your pellets and produce whatever they need to using your pellets. Is that kind of, do I have that right on your structure?
We're focused on working with packaging distributors who already have relationships with thousands of brands, like your favorite brands already source packaging from them. Our strategic partners at 𝗡cie𝗁𝗯𝗶 have brought the 𝗶cie Innovation Coalition to life. So 𝗶cie is creating this entirely new material. We're figuring out how to scale it. We're scaling it up. But then 𝗡cie𝗁𝗯𝗶 takes that material, turns it into bags, prints it with algae ink or whatever else, customizes it to their customers' needs and gets it into the world. And then what I really love as a designer is still working closely with the brands to help tell the story of seaweed, of oceans, of regeneration, of compost. Even though, we're not selling directly to them, we really take our partnership seriously because materials and entirely new materials entering the market are only successful if people understand them. And material science can feel really overwhelming and intimidating and complicated. And as a non-material engineer, I love to do the job of saying, actually, it's just like cooking. Seaweed is this, gorgeous, generous feedstock, kind of drawing out some of the simplicity and the beauty of the material in an accessible way.
Amazing. And so you mentioned printing. So it works just like other thin film plastics, then you can print on it, you can do any of those post operations and it reacts similarly. Can you hot knife it? Is that, because I know that's how we make a lot of bags, of like just hot knifing it, and so you're able to just use whatever tools there's no kind of limitations that way.
There probably will be limitations. We haven't encountered them in terms of converting the material into bags. The beauty of designing it for this existing system is that after you've produced it using the existing system, all the subsequent systems tend to also work. The challenge we'll run into more so is the ink compostable, or is the adhesive to seal the bag compostable? Those are the challenges we'll run into more. But in terms of manufacturing and printing, it's one for one.
Amazing. Well, it makes it so easy. Sounds like so you have interested companies from the brand side. It sounds like you have plastics companies that have all the tooling and everything who want to use it, and who all has been really interested just in terms of like vertical wise in this material, because I feel like there's so many uses for it.
Yeah, sadly, the sky's the limit. We've started with a focus on fashion because there's a huge amount of pressure being put on fashion brands to get plastic out of their supply chains. And there's a great opportunity for storytelling within the fashion industry. We have such an emotional attachment to the things that we wear and the brands that we follow along with. So I think it's a great place to, write some messaging about the story of seaweed. There's a lot of real estate. We're also interested in fashion because last year 𝗶cie won the first place in the Tom Ford Plastic Innovation Prize, which was organized by the ocean nonprofit Lonely Whale. And Lonely Whale has done an incredible job of connecting us with all these amazing fashion brands, including some of the ones we're still working with. J. Crew, Burton, Herman Miller all tested our materials as a result of winning this prize. And so we got all this validation and feedback from them. And now we're focused on, really bringing the material out to the fashion world at scale. But other industries that really have a lot of plastic are the food industry. So that's up next, figuring out how to get plastic off your food, your chip bag, your Snickers bar, those kinds of things.
Right. Well, and food is interesting because it's always, well, not always, most of the time it has a lot of moisture in it compared to clothing, which shouldn't have any in it. It's a whole different ballpark you're playing in. Now, I'm curious because you talked about getting it to be resistant to moisture and stuff like that. Is it something that you can actually fully seal in? Like waterproof? Like how much proofing can the material do typically?
We're designing to eventually be able to package things that are wet or maybe have a longer shelf life, but it does take time. So right now we're focused on dry goods, clothing, electronics, home goods, cosmetics. There are plenty of categories where there's not a lot of moisture that you're trying to keep in. You're just trying to keep the moisture out. And we're working our way up to food packaging, which does have this really high bar to clear in terms of, how much moisture you might be trying to keep inside and how long that thing needs to sit on the shelf.
Yeah, shelf life. That's a whole that gets hard. It's hard for sure. Well, I love the product. I love what you're doing with it. Fashion, I definitely agree, is a big space that needs needs as much help as it can get. And I love that food's next because I feel like that's just another massive, so much plastic like this gets used. So right now, what's next for you guys, it seems like, is it going into production? You have these tests that you're doing that you'll have results from. Kind of what's your depths over the next couple of years? Like, where do you see this? What's your goals for it?
My dream is that as we grow, we wield a little more influence on both sides of our supply chain. Our mission is to create materials that replenish the planet from sea to soil. So the technology has got to be successful. It has to do a great job of packaging things. But then if we're really successful, we'll have expanded demand for cultivated seaweed. And if we do it right, more seaweed means healthier oceans. And then as we expand the use of compostable materials, if we do it right, more composting means more healthy soil. I hope that both sides of this spectrum are growing so that as we succeed, our success is interlinked with the health of the ocean and the health of the soil, who are our two largest carbon sinks on Earth.
Yeah, I hadn't thought about that. The fact that you're going to more seaweed, and definitely logically, right? More seaweed is good for the ocean, but nobody is incentivized to plant a ton of it, get it to grow, unless you start driving up demand for it, which is great.
Yeah, I think it can be done responsibly, but we're one startup operating in collaboration with a lot of amazing ocean NGOs and research organizations. And we're not by any means doing this by ourselves. There's a lot of energy going into investing in our oceans right now.
Yeah, well, they're pretty important. They're kind of special to helping our life as we know it. So
every other breath you take is, thanks to the ocean.
Absolutely. Well, I really appreciate you taking the time to talk through this and share what you guys are doing. It's amazing to see this material happening. I'm so glad you guys are close to mass producing it. Hopefully I can start to see this in my Amazon packages maybe in a few years, just there.
That's the goal.
Not even have to think about it again. Yep. It'll just be there. I'll know that it's biodegradable and not have to worry about it again or feel bad about all the plastic that just gets shipped with everything. Kind of to wrap up, for anybody that's interested in working with you guys, maybe be able to test out your material, see if they can use it, where's the best place to reach out and connect with you guys for them?
𝗚cie𝘁𝗯𝗹𝗲𝗠 If you're a brand or you represent a brand that's interested in using our material, 𝗚cie𝘁𝗯𝗹𝗲.com/pilot. And then if you just want to follow along, we love engaging with our broader community of ocean enthusiasts and packaging fanatics and composting practitioners. So at 𝗚cie_the_future on every social handle, but especially Instagram. That's where to get your content.
Amazing. And for everybody listening and watching, those links will be in the description for you guys for easy clicking. Well, thanks for being on. Appreciate it.
Thank you, Ian.
And that wraps up another episode of the Conscious Design Podcast. If today's episode inspired you to bring your product idea to life and turn it into a sustainable 7-figure business, visit petermanfirm.com or click the link below. Your ideas have the power to change the world, and we're here to help make that happen. Thank you for joining us, and I'll see you on the next episode.